Welcome, everyone. Welcome to this fourth session of Quantum Computing in a Nutshell, powered by Open Science Labs Brazil. This is an open source quantum computing lecture series, which is powered by Open Science Lab, which is an international organization. In the last sessions, we have discussed about the fundamental concepts which are associated with quantum computing as well as quantum mechanics. For this particular session, within this session, we are from the upcoming sessions, we are going to directly dive into the field of quantum computing. I hope this would be the last session which we are going to discuss about the general theories which are associated with quantum mechanics, as well as the understanding of science among the people, which we are really needed for the furthermost understanding of quantum computing. I foremost welcome all of the participants who have joined in this live session, as well as people are watching the YouTube live stream, or maybe you are watching in a recorded stream. If you have any doubts, you can directly contact, or you can directly interrupt during the meeting. Also, you can directly put your doubts in the YouTube chat box, as well as comments, so I can rectify as much as I could. First of all, today's session, we are directly diving into our session. Uh, I hope, one second, let me screen share my screen. Okay. Okay, I hope my screen is visible to everyone. Well, for profound introduction, I am Sri Kaleshwarar, an MSc Physics student from Tamil Nadu, India, and an open source developer and an enthusiast who is closely associated with Open Science Lab, which is an international organization which is works for open source science developments. In the earlier sessions, we have actually discussed various topics in terms of quantum mechanics, like the wave particle duality, Heisenberg's uncertainty principle, Einstein's photoelectric effect, and some other basic concepts which are associated with quantum mechanics. But most of the people ask me personally why we need to learn quantum mechanics. Second. Why we need to learn quantum mechanics? But we are just here to learn just about the quantum computing. Why we need to understand the basic core concepts of quantum mechanics? Well, basically, the thing is, we are here learning how to manipulate those atoms, which we are atoms or maybe ions, which we are using inside a particular chip, which we are calling it as quantum chips, or maybe photonic quantum chips, ionic quantum chips, or some other things else. We are actually manipulating those qubits. We are actually manipulating those atoms to act as a computer. We are using them using the wave function, which is the Schrodinger's wave function, and other properties to analyze those data which we are getting out from the particular device, then which we are using to do computations in terms of using the quantum computers. We have to learn the basic concepts which are associated with quantum mechanics. In the upcoming lectures also, we are going to discuss about the Shor's uh, sphere, also the Hilbert spaces, and some other deep complex mathematical terms. But in this fourth week lecture, we are going to discuss about some of the most common doubts which are associated not only with quantum physics, not only with classical mechanics, not only with physics, not only with science. Every people have these kind of doubts. Why we are going to learn about science? why we need to do these kind of improvements. Like the main thing is we are already having mobile phones, we are already having devices which we can easily use them to do our task. Then why we need to create these kind of new innovations, and why we need to use these kind of complex equations to explain the universe and things like that. So in this session, I have some general questions which I earlier have, and I have somehow those answers for those questions. We will deeply discuss about these questions, and I will try to answer this question, because the title itself, I say, like big answers to the tiny questions. Some people would say like these are just silly questions, like just you can see what is actually the energy. Most of the people would say the work done means energy and something like that. We have a physical meaning, or if you look at some other subjects, there should be some philosophical or scientific explanation for everything. But we need to understand why we are learning those things, and why, where we have to correlate these things with the real world. So I have collected somehow 10 to 15 questions which I earlierly have, and I somehow find so some of the answers. But also in this live session, I appreciate each and everyone have participated and going to participate in this session. Kindly ask your questions. It may be way too complex for me to solve, but I will try my best to answer those questions. If I fail to answer, I will try my best to collect those information and try to answer in the next session. And if I couldn't able to answer, and the scientific community couldn't able to answer, welcome. You have find a new theory for quantum mechanics. You have find a new phenomenon on quantum mechanics, or maybe in the physics. So I hope this session would be interactive for this thing in the upcoming minutes. First of all, I thought I could start the things from here onwards, I think so. Why do we need quantum theory? Well, actually, I had discussed this topic earlier on my first session too. Why do we need quantum theory? Like in school days, we already learned about the classical mechanics and the classical physics, which is founded by which is originated from the Newtonian mechanics, and as well as Lagrangian, Hamiltonian mechanics, and some other things. We have a tons of coordinates and some other things. Then why we need a quantum theory? In the second lecture, I have already explained the ultraviolet catastrophe and some other things which led to the scientific society to create a new theory in terms of classical, which is improved version of the classical physics. We came across with a new theory with how does the atom orient. We had explained about the shells and the energy levels and the a new way of periodic tables, and how does an atom works in the space, the n-dimensional properties, and etc. The light matter wave matter duality, and predicting molecular behavior. There's a ton of needs. That is why we had found the quantum theory. It is used in various kind of fields nowadays, but most of the people have that. Most of the people thinks that the failure of classical mechanics is associated with everything. But according to my point of view, actually classical mechanics doesn't even fail. It is just wouldn't be able to explain the ultraviolet catastrophe and some other phenomena which are physically available in the nature, which is tiniely available in the nature. But in most of the cases, most of the real world incidents, classical physics still be able to explain most of the things. The crazy part is we are still using classical physics for launching rockets. The most of the rocket science equations are derived from the classical physics. Most of the people think that classical physics died once the quantum theory was emerged, but we are just using this quantum theory for manipulating atoms and the study of nuclear physics and some other limited fields. We are currently using quantum theory. Um, we can use obviously we can use the quantum theory for everything, but currently we are using them for the quantum level objects. Most of the people think that why we have. A second. Okay. Most of the people, the another question is why do we have so many physics disciplines? This is also another important and most frequently asked question in physics. Why we have a ton of disciplines? Like we actually have a single atom on our hands. Like everything consists of atoms or maybe fundamental particles or some other things. Then why we don't? Why we had to use a ton of theories to explain each and everything? Because the main problem is up until this moment, we don't have a single efficient theory to explain every physical phenomenon. Because in the classical world, the real world, we are using classical mechanics, or which is derived from the Newtonian mechanics and Lagrangian as well as the Hamiltonian equations. For thermal properties and some other engineering disciplines, we are using thermodynamics, and for some other probabilistical and statistical analysis, we are using statistical mechanics. For space, we are using astrophysics, cosmology, theory of relativity. For electrical and electronic things, we are using electromagnetism and some other theories. For nuclear physics, we are using particle physics and nuclear for nuclear interactions. For quantum level objects, we are using quantum mechanics. We are having it is like a mesh. Somewhere classical mechanics and quantum mechanics contradicts with each other. Somewhere the classical mechanics and the particle physics contradicts with each other. There's a ton of chaos in the field of physics. Since we have a ton of disciplines, we still confused with one another. But the main agenda of the current world world class physics institutions are just to find a confined single theory to explain all the physical phenomena which are available maybe in the universe. And also I think we can move to the another question. Most of the people think that why we still use the classical physics, like classical mechanics. It is like we can observe everything in the classical physics. Like the classical world of the classical interpretation of the physical world is entirely different from the quantum interpretation of the physical world. Like we can easily explain how does the trees grow, how does the mechanical engine works, how we can build bridges, how we can send rockets to the uh, extraterrestrial planets, or how does the projectile motion works, how does the thermodynamics works, how does the continuous motion, the linear motion, and some and most of the real world observable physical phenomena we can easily use classical physics. The main thing is why I am correlating classical physics with quantum computing, because the current modern day computers which we are currently using, maybe an Intel processor or maybe a Ryzen processor or maybe anything which you are currently using right now, are all are made out of it. Sir, can you mute for a second, please? Or if you have, okay, thank you. The current world things which we are currently using right now, like most of the computers which we are using right now, like maybe it consists of Intel processor or maybe Ryzen. Everything runs on the basic core principle of classical physics, or maybe we are using classical computers. The technical term is the quantum computer should be the new era of computing. We are currently using those classical computer. We are currently using those classical bits, or maybe a switch case statement, like if we have a zero state or maybe a one state, we are just manipulating those transistors, which is made out of those logic gates, and we build flip flops from them, and we create and manipulate those data interpretations. And we had built an assembly language over there. We built those hardwares, then here comes the programming languages, here come the operating systems, which is like a complex and which is like a complex classical system which we are currently using for our computational purposes. The main use case of classical physics, in my point of view, is we are currently using those classical computers. We are still using those classical physics to explain, to understand the world. That is the main thing which we have to think of it, because we are using quantum mechanics, we are using quantum physics in terms of in terms of some specific places only. We are not even completely switched to the quantum mechanical world. There may be a ton of contradictions over there, but most of the people think that we had discovered the quantum theory, or maybe we have invented the quantum theory in the earlier 20th century. Then why we are still using those extinct theories called classical physics? Because classical physics, it is enough for explaining those everyday phenomenons, those everyday things, those everyday engineering which we are currently using right now. So even after the invention of quantum computers, even after the generalization of quantum computers, there should be, I hope, people would use classical physics for most of those calculations. And maybe I hope that in the early, very future, we may have a very new theory to explain each and every physical phenomenon which are associated to the universe. And here is another contradictory question which I came across in my chat box. Like, who created the universe according to the quantum theory? One of my follower from UK asked this question. There should be something. Something should create this universe. Initially, Newton believed that the universe is consist of a solid state theory. He proposed a solid state theory, and some other scientists who are associated with some philosophical ideologies, they proposed a tons of theories in terms of the birth of universe. And most of the profound and agreed theory is the Big Bang. Most of the people think that the journey of the universe started from the Big Bang, maybe from the singularity, and even today the universe is expanding. There's a theory of relativity, and tons of things are associated with that. But in terms of quantum physics, in terms of quantum mechanics, there is still uh, lot of speculations. Like, according to string theory, which is closely associated with quantum mechanics, it states that everything is a string. Maybe a particle, maybe a kaon or a photon, or maybe an electron. Everything is like a vibrating string. Then how does something going to create some other thing? Because in the theory of relativity, there is nothing before the beginning. The theory of relativity wouldn't be able to explain what is before the state of the Big Bang. But we are still, the scientists are still working in terms of the basic understanding how does the universe emerged from nothing to this gigantic expanding universe. And scientists are still working on those things in terms of quantum theory also. I hope we may found a profound theory which can explain the birth of universe with the help of quantum theory, maybe. And most of the people also ask me, is that we really using quantum physics in our day-to-day life? Well, especially actually, I earlier explained that we are currently using devices which are based on classical theory, but the fabrication of those tiny little transistors, because even from the first hour lectures which I have started earlier, I'm still saying this example, like having a mobile phone in my hand. It consists of billions of transistors inside of it. So like we are currently able to fabricate those transistors with a nanometer precision. So we are using quantum mechanical band theory. In terms of photosynthesis, there is interaction between a photon and leaf, or maybe there is an interaction between the light particle and the living organisms which creates the photosynthesis effect, or we are maybe using in the MRI scan devices and GPS satellites. Particularly this photosynthesis topic, which I have earlier discussed in the last session about the bioquantum informations, which is also one of the most fascinating fields in terms of quantum research. You can also check those videos on bioquantum information. There is a ton of use cases still. Actually, we are using quantum physics in the real world too currently. Does quantum information means I am eternal? This is one of the most fascinating questions which I have came across in the internet. Which has, one second. I hope this would be perfect. There is a theory like, if a person went into a black hole, is correlated quantum information would get also be lost. Like, everything is predictable, everything has a probability in terms of quantum physics. So technically, we can recreate a phenomenon, we can recreate a we can recreate a particle, we can recreate an information in terms of quantum mechanics. That is the basic core concept which we are currently using for explaining those quantum computers. Because let me imagine this, maybe this tiny mobile phone is a quantum chip. We are just making some particle and particle interactions, we are just getting some wave patterns, and we are just analyzing them, and uh, using those probabilitical equations and using some other highly precise devices, we are just predicting that, we are just probabilistically saying that we have a zero state, or maybe one state, or maybe another state. This is just the basic core concept of the quantum cryptography which we are currently using right now in the field of quantum computing. That is the core concept of quantum information also. Most of the people ask that, if the quantum information is immortal, so let me imagine some particle is over there. If it is even lost, or it may be collided, or the energy state is differed to billions or trillions of time, if we find a perfect or a precise quantum theory, we can retrieve the quantum information. That is the main core thing which are associated with quantum computing also. We are currently in the IBM research centers, which are associated, which are located in USA or any other quantum computing research centers. The scientists are currently working to reduce those quantum errors and trying to improve the retrieval of the quantum information, because they are currently just manipulating those atom or a particle particle interaction. They are just observing the information which may be output wave or some other thing, and they are just trying to predict and trying to get a very high probabilistic value. That is the thing, they are currently working with that. And also, I am currently building a research paper in terms of quantum error correction also. Maybe I will going to explain about it later on this lecture series, maybe in the 10th or maybe 11th episode, I hope. Also, it is also a vast and fascinating field, which are also way too important for us to understand about the quantum information retrieval, which is also, there is a ton of scope in the field uh, in terms of quantum mechanics also. And also some other questions like, I'm just living a normal life, I'm just having a maybe a 3 BHK apartment in the New York, and having a very good family. Why don't I have? Why does I have to care about the quantum theory or maybe quantum mechanics? This is the most of the common people would ask, like, why I need to learn science? Why I have to care about science? In some day I will going to die. then why I have to philosophically think about the quantum physics or maybe quantum mechanics? But according to my prediction, as a student, as an aspiring researcher, maybe in the very future, we can able to manipulate or maybe predict or maybe able to uh, use the quantum level approaches to extend the life expectancy of humans. Also, we can able to predict what happened in the past or what are going to happen in the future. Like according to the some research papers which I have gone through in the internet, like maybe in the very future we can able to create a small tiny quantum simulation worlds where we can do some quantum mechanical simulations, and we can create a simulation. We can maybe able to create a simulating world where we can test those drugs and some other things which we really need. And maybe in the very future, maybe after a few generations, we will have a very high level medical treatments or some other things, which is way to associate, which is an integral part of the human evaluation. So we cannot overcome or we cannot just leave the importance of quantum mechanics as well as quantum computing for the future. Also, one of the most frequently asked question in my sessions are, how can a non-living particle create life? Well, there is still a very big vacuum to explain this theory. Like, let me give you an example. My nails are made out of calcium atoms. Maybe this mobile phone, or maybe these coins, or some other things which in my room may consist those calcium or atoms also. But my nails have a life. It is consist of DNAs and RNAs and tons of biological things. Maybe billions of maybe thousands of microorganisms also living in my nails. But how how a complex series of atoms which able to create a life, which is still a fascinating doubt in terms of not only in terms of physics but also in science also. We already know that these atom molecular interactions we create amino acids, nucleotides, and nucleic acids, maybe RNA or DNA, and which creates living cell organisms and other things. But why we have to include biology in terms of quantum computing? Well, currently we are currently using those medicines like which we used for example for COVID-19. We had used a variety of vaccines, maybe an RNA vaccine or a DNA based vaccine or some other protein based vaccines. We have used a ton of varieties. We are still using this kind of like we are still using complex structures to solve our medical problems, or we are currently using complex structures to create medicines. But maybe in the future we may able to find that the skin cancer not only caused from the UV rays, but maybe a direct interaction between the UV photon and a small carbon atom in my skin, which causes this is just a theory, like maybe hypothetical theory. This interaction creates those skin cancer. Then maybe in the very future, using the quantum computing chips, we can able to solve those things. We can may have a quantum precision medical equipment in the future, so we can cure most of the current world human diseases. Or maybe we have high precision devices which we can tear apart those RNA or maybe DNA viruses, because everything consists of quantum particles. So maybe in the very future we should really need the quantum computing field. in terms of biology also. For more information, you can watch the last session which I have explained about the bioquantum information also. And this is the most common, and why we are talking about quantum computing in the 21st century. Like the theory which is originated earlier in the 20th century, after hundreds of years, after even after 120 years, why we are announced 2025 as the world quantum year, or maybe why we are talking about quantum computing here right now. Well, basically, the main need for quantum computer is currently our daily life computers are like a manual machines. It can start from 1 to 10 in a manual sequential way. Even though we are having supercomputers and some other things, we can't be able to predict, we can't be able to simulate real world incidents. Like, for an example, if I hold something in my hand, like this mobile phone, it has n number of atoms. Like using Avogadro number, we can find how many atoms consist of this particular device, which weighs around 200 grams. Uh, there's we can't use a computer to simulate a quantum level simulation of a 200-gram or maybe a single gram of real world matter. This is way too important, and using those normal computers, we can't able to do the mathematical series for a particular distance. Like we can calculate from 1 to 100 using quantum classical computers. Using these quantum computers, using this superposition principle, like we are having qubits like at the same zero state and the one state, we can able to manipulate, like the classical computer which able to count from 1 to 100 in 10 days. These quantum computers can easily do it within a second, because we are using superposition. We are just manipulating zero state and the one state simultaneously using the wave equations, or maybe the wave patterns, or maybe using Fourier transformation or some other things. This is the very future which we are really needed for. I think so, which is also the main purpose for conducting this session also. And the main thing is, we are in the generation of AI. Most of the people think that AI is an intelligent device, or it has its own intelligence, like which I have in my brain, like neural connections. Most of the people compare with neural networks with the with the human brain. But in the core reality, this classical AI models, uh, which I'm talking like ChatGPT or maybe Cloud or maybe any other AI model which are available in the current market, which are can be called as classical AI models, which all of these classical AI models, these are we can't compare these AI models with the upcoming quantum AI chips, because these models are just large language models or some data manipulating models. If you search for something, if you search for a physics statement or a quantum theory or maybe a capital of a country, if you search and go and search for ChatGPT or some other AI models which are available in the day-to-day world, these are just giving some information. But in the very future, the quantum AI will able to do what we really need. Like we can install our own laboratories in our home. We can really simulate the particle-particle interaction without any need of using the real world things. We can actually simulate high potential, high precise simulations in the real world. That is why we are really need to. It is not a request, but it is. the correct and the perfect moment for us to learn about the quantum computing, because in the very future, in the near future, everybody would have a quantum computing AI chips, which are currently working, which are the current dream projects of Google and IBM or some other world companies. But in the very future, we will have cloud-based quantum AI chips. We can directly access them using our these kind of classical mobile phones, and we will have a very fast and advanced AI technologies, not just an artificial intelligence, which can the true quantum AI intelligence can be able to fight or can be able to compete with the real human brain. So, like, it is the perfect moment for us to learn about quantum computing. If we lost in the race, we may be failed to make through the perfect path of the evolution. Like, it is just another part of evolution in the human evolution chain, I think so. Human evolution cycle, I think so. And here comes I think the final question. What is actually the energy? One of my friends, every time, even before I started this lecture series, even before I started writing science articles, my friend actually asked, what is energy? According to the philosophical understandings, we have a ton of classifications, like maybe God created the energy, or maybe some other interactions created the energy. What does it mean by energy? According to my point of view, in terms of quantum mechanics, energy should be a particle. It should be propagating like in a waveform, which we are currently using to understand, or maybe it is a string. It may be a particle, it may be a string, it may be an unidentified thing, which we are still trying to explain. Like, we are still having some manipulations, and we are still having some hypothesis. Like, E is equal to mc square means the energy should be equal to the mass and the square value of the velocity of light. There is just still an assumption. According to the Planck's hypothesis, we are having E is equal to h nu, a constant value and the frequency. We are still trying to explain about energy. Because why I leave this question for at last? Because according to my point of view, if we are truly able to explain what is mean by energy, then that would be the final page of the discover of the exploration of physics. If we able to explain the true statement about energy, what is the true understanding about what is the true meaning of energy, then that would be the last chapter of physics. Because here I want to remember the famous quote of Richard Feynman, Nobel laureate and renowned science communicator from the United States of America. He once famously said that if you feel like I have learned quantum mechanics very well, then it means that you didn't learn the quantum mechanics very well, because it is all just hypothetical analysis, and we are still trying to solve those questions with what we have really, like with the help of the mathematical equations which Newton had. He introduced the integral calculus and differentiation and some other new things to the field of mathematics and physics, which created a new discipline called physics. Then we moved into the Lagrangian and Hamiltonian equations and some other polar coordinates and some other things, and we combined tons of disciplines. We forcefully fed tons of discipline into physics, and it created the new fascinating field called quantum theory. And in the golden era, the 20th century, we have made a ton of discoveries in terms of physics. In the 21st century, we are in the century of quantum computing. We are in the century of quantum theory. And I hope we still have around 7 decades to go finish this century. In the very future, maybe in the upcoming decades, we will surely not only have those quantum computers, we also have new theories to explain the new chapters of physics. I hope that would be the real answer of those tiny questions. Also, uh, from now onwards, I'm going to stop the live streaming, and I hope some of the people have joined in the session, so we will have interactions after the live session. First of all, let me stop the live session. And one more thing, the next or maybe the fifth lecture series will be continued on 25th of July 2026 at the same time at 10:15 p.m. Indian Standard Time, or maybe 16:45 UTC. If the participants having any doubts, you can ask me directly. Once again, I will stop the live streaming from now onwards. 1 second.